Well, this is the swing arm spindle out of the Sport that I'm recommissioning, and there's not a lot of wear in the pin, but what wear there is unfortunately very uneven, and I don't know if you can see that line on there as I rotate it, but that's actually a raised ridge where it was lining up with the a groove in the swing arm bush, and the other side there's no wear at all here. That's a completely untouched surface, and although there's not a lot of wear, there's a bit more wear in the bush, which is cast iron. Unless the wear is kind of acceptable. You'd get probably an advisory at the MOT, at the annual safety inspection, and it would probably last quite a while, but unless I get this pin back in exactly the same orientation that it came out, I'm now going to have that ridge not sitting in its original position, and it'll wear quite rapidly, so this really does need to be replaced along with the bushes. And I thought about reducing this diameter slightly and making a custom bush for it, but these are hardened and they were originally ground, so it's not particularly easy. So I'll do what I've done before, and I've got to this stage. I got the stainless steel material. This has got the two bearing surfaces. There's a slight relief in the centre. This diameter is correct. This one is still to be taken down. It's a 20mm. Both threads are 1.5mm pitch. That's a 20 and that's a 14. So I've got to get that down, and then the two threads can go on. So we'll go over to the lathe and check on the setup for metric threading and get this done. This was an example of where one job turned into another, and I ended up doing a job that I've been putting off for a long time. I've upgraded the VFD to include braking components with a braking resistor, and in setting up the metric translation gears, that reminded me of the way the power was originally wired, and which I didn't want. And if I open the gear cover, you heard a slight click. That was from the interlock micro switch, and you'll notice that the light has gone off on my control panel. Now, as this was originally wired, it actually cut the power to the lathe, cut the power to the inverter and the DRO, and indeed the light, which is running off that outlet box I've got down there. So I didn't really want that, so in replacing the VFD, I've just wired the interlock micro switch into the stop circuit along with the other controls. So we've got the threading chart provided on the inside of the cover for metric. So we're cutting a 1.5mm thread, so 50 tooth on the chop shaft, driving a 40 compounded with a 60, and the 127, which gives this our perfect metric translation. And then we run the threading gearbox in the 20 TPI position. So we've got the 50 at the top, and this, by the way, is a special undersized gear, and it does clear the spindle extension. Normally at this position in the gear train you have a fibre gear, which I have here, which is also a 50. If you try and put the 50 on the top there, it will foul the spindle extension, so that is a slightly They just topped the teeth slightly, so it goes on there. So that's driving the 40, in here the 60, and the big 127, which when I bought the lathe was still in its factory protective coating and wax paper wrapping. Yeah, the micro switch just up there, by the way. So then we have the gearbox set for 20 TPI with the two levers both to the right and the pick-off selector in that column. And I did a test earlier and I've confirmed that it is indeed, there's a scratch test on there, which is 1.5 millimeters. So I shall get everything set up and we shall cut some threads. I've got 3 swing arm pins on the bench here, and the first one is the one out of the bike. So I decided to do the usual thing I've done in the past few times, which is to make a stainless steel pin. I mean, these are 18 millimeter diameter, so they're pretty substantial. And I had done nearly all the machining on one, and I was just putting flats on the end, and as you can see we had an oops, and I must have just not had the chuck on my super spacer properly tightened. I mean, I'd done 3 flats without any trouble at all, and then I just started the first and it grabbed it. And it's still usable. I wouldn't put it on a customer bike, but it will go on the shelf, and go into one of mine I'll complete putting the flats on the end. So I started again and made another one, and this time didn't have an oops, got the hex on the end. I prefer to put a hex on the end. The originals just had a pair of flats and can be a little bit of a pain to turn. So that's now all ready to go back on the bike. Well, I've got to press the worn swing arm bushes out of the swing arm. There's no easy way to get it in there, so I had to come up with a little ingenious setup. See if we can juggle this. There we go. Just enough room at this table setting. Get ourselves centered up as best we can. Let's give this a go. Swap sides. Get some leverage on this. Well, it's out. The original bushes are cast iron, and if kept lubricated properly they do survive, but they usually are neglected and then they wear quite fast. So let's see if I can find all the bits, and we'll repeat the procedure on the other side. So it's a bit more cooperative. Okay, that's both bushes out. And I'm making PTFE bushes to go in. I've done a fair amount of cleaning up on the bike just to make work easier. There's a tray full of stuff that I scraped off the frame, particularly around this swing arm area. It's not just the usual stuff you get from chain loop being flung. The swing arm's all been cleared up. I've got it hanging on the rear suspension units to make things a little easier. And the new Teflon bushes are in place, so I should just be able to wiggle, get that started. Now you have to go around the other side, get that lined up. Let's come back a bit. Now I've talked before, and I did a video about adjusting the side play on the swing arm, and people say, oh no, it's done with shims. Well, it's not adjusted with shims, but there might be shims, and this is the one that came off this bike. It's to do with the tolerance on the way the frame was made, that if there's room for a shim, they put a shim in to take up the majority of the play before using the pin to pull the side plates in. You know, that's actually quite a thick shim. That's at least a millimetre, if not more. So you don't really want to be flexing the plates that far in with the swing arm pin. So this is a slim spacer rather than an adjustment shim. So I've got to get around the other side and get this in place. Now, if I adjust the angle a little, you can see there are these bolt-on plates, and these should be left loose until the pin is in place, because it can hang up on them. Where have we got to? Just going to use that wrench on there to make things a bit easier. I make these pins to be a fairly tight fit in the Teflon bushes. we're actually started in the bush the other side, so I need to come back a fraction just to get the washer in place. Or the spacer or shim or whatever you want to call it. Shim is on. So the end of the pin is now started in the other side of the frame. I just need to get the threads to catch. Okay, that's got it. So now, the idea is now to wind the pin in all the way. Until it bottoms out on the frame on the other side. So now we find out how much side play there is. And back off the pin a little. And now fitting the nut on the other side will pull the side plates in and take up the side play.